Okay, part 7, and again, we're given, a question, and there's multiple choice. Certainly be nice to be able to think through that problem and come up with a legitimate answer, by the way. Number 2, these are infinite sums. These can be incredibly difficult to do, especially if you don't see the pattern to it. But the bottom line is, if they're asking a question, you can do it, by the way, all right? So over here, the other one, closed form. This looks like a familiar question to me, by the way. And I think we've seen this one prior where I went from n equals 1 up to, I think it was 9. I can't really remember exactly, all right? This one, number 4, says use half-angle identities for cosine and the identity presented above. I guess this one over here, by the way, or maybe this one over here, who knows, to drive an infinite product formula for pi, all right? So again, it requires some thinking, by the way. But again, if you're not willing to think, it might be a really difficult thing to do, all right? Number 5, it's a question that we've actually seen before, all right? This has something to do with the exams that are given in India, which do require memorization. And the reason I'm saying they require memorization, if someone's given 1.5 minutes to solve this problem over here, you'd have to remember something to do that very quickly, by the way. Now, if you didn't and you're trying to derive, something to figure that out, that takes more than 1.5 minutes, by the way, all right? But anyway, what do? I provide not only the questions again, but the questions with the video answer and me working through the problem, all right? Again, a video and me working through the problem at the whiteboard, all right? And, number 3, a video and me working through the problem, all right? Get that, the nth partial sum. Number 4, that was one, a little confusing to read it, using half-angle identities for cosine and the identity presented above. I wonder what identity they're talking about. Oh, you know what? I guess we've done something in the past like this before. Who knows? Maybe I should rewrite that question, by the way. But there's an identity over here, and certainly writing down what an answer looks like, all right? And again, this is kind of a unique experience, by the way, coming up with an identity for pi that involves this expression over here. And it's an infinite sequence. I'm sorry, an infinite product of 2's on top. And you got this infinite nesting on bottom, by the way. Looks really kind of crazy. All right. Number 5, you'd have to know something. I did say in the past we could prove this, and we did prove this over here. This is something that students maybe in other countries would think is something to recognize, right? I would say in the United States, by the way, and I'm not an expert, but I think most schools do not present this as an identity to recognize and to be able to reproduce, by the way. But again, I do derive it, and the derivation's right over here, by the way. And again, the video, I also walk you through that. And someone says, why is that? A student taking this exam, by the way, would recognize this problem here as being this identity over here, and I write the answer down really quickly. Whether I write down the b minus a, 4 minus 2, divide by 2. And again, they do it really quickly, all right? So that's about it, all right? Thank you for paying attention.